Hey everyone, and welcome. So, you deal with numbers all day, every day, right? But have you ever stopped to think about what they really are? Well, today we're jumping straight into a super important chapter for your ICSE Class 9 syllabus, rational and irrational numbers. And trust me, by the time we're done, you're going to look at numbers completely differently.
So rational or irrational, what's the actual difference? What makes one number rational and another one, well, irrational? That's the big question, right? Let's dive in and get this sorted out once and for all.
Okay, so think of it like this. You have this massive universe of numbers that we call real numbers. And inside this universe, there are two big competing families. On one side, you've got the rational numbers, and on the other, the irrationals. They're related, sure, but they behave very, very differently.
So first up, let's get to know the rational family. These are kind of the well-behaved, predictable guys. They're orderly, they follow a set of rules, and you always know what to expect from them.
And their main rule, their golden rule, is super simple. Any number that you can write as a fraction, p by q, that's a rational number. The only catch? The denominator, the q at the bottom, can't be 0. That's it. As long as you can put it in that p over q form, it's part of the rational club.
Now, when you look at their decimal form, rationals have two main personalities. Either they're terminating, they just stop, clean and simple, like 0.5 or 2.75. Or they're non-terminating but recurring. That sounds complicated, but it just means they go on forever, but in a really nice repeating pattern. Think 0.3333 or 0.141414. See? Super predictable.
Okay, here's a pro tip for you, a real game changer for your exams. How can you tell if a fraction will give you a terminating decimal without actually doing the long division? It's all in the denominator. Just break it down into its prime factors. If the only prime factors you see are 2s and 5s, it will terminate, guaranteed. Any other prime factor in there, like a 3 or a 7? Nope, it's going to be a non-terminating recurring decimal. It's a fantastic shortcut. All right, theory's great, but let's put it to the test. Here's a classic problem you'll definitely see. We've got a bunch of fractions, minus 5 by 9, 7 by 12, minus 2 by 3, and 11 by 18. The task? Arrange them in ascending order, from smallest to largest. Let's do it. Now, you can't just compare these as they are, right? The denominators are all different. So here's our simple three-step method. Step 1. Find the LCM of all the denominators, in this case 9, 12, 3, and 18. Turns out it's 36. Step 2. We convert every single fraction so it has 36 on the bottom. And step 3, the easy part. Just compare the numerators, the numbers on top.
And look at that! Once we convert them, everything becomes so much clearer. Minus 2 by 3 becomes minus 24 by 36, minus 5 by 9 becomes minus 20 by 36, and so on. Now it's a piece of cake to see the order. Minus 24 is the smallest, then minus 20, then 21, and finally 22. So our final order is right there. See? Simple.
Okay, we've met the orderly, rational family. Now, let's cross over to the wild side. It's time to meet the mysterious, the unpredictable, the irrational numbers.
These guys are the absolute rebels of the number world. Their decimals are non-terminating and non-recurring. That means they go on forever and ever with absolutely no pattern. It's just endless chaotic digits. The most famous ones, you've heard of them. Pi, or the square root of any number that isn't a perfect square, like the famous root 2. So how do you spot an irrational number in a problem? The trick is to always simplify first. If you simplify everything and you're still left with something like a root 2 or a root 5, well, you've got an irrational number. But watch out. Sometimes things can look irrational, but they aren't. Like in that second example, the root 5s cancel out, and you're left with 20, which is totally rational. So yeah, they can be a bit tricky.
All right, now for a power move. This is a skill that will get you marks, for sure. It's called rationalization. It sounds a bit scary, I know, but it's basically our secret weapon for taming those irrational numbers, especially when they show up where we don't want them.
And where don't we want them? In the denominator of a fraction. It's kind of an unwritten rule in math. You just don't leave a square root sign in the denominator. It's considered messy. Rationalizing is just the process of cleaning it up. So how do we do it? We use something called the conjugate. And all that is you take the denominator and you just flip the sign in the middle. So for 2 plus root 3, the conjugate is 2 minus root 3. Simple, right? And the magic happens when you multiply them together. You get that old difference of squares formula, a squared minus b squared, and poof, the square root disappears. It's a fantastic little trick.
Okay, you've got the concepts, you've got the skills, it's time for the final boss battle. Let's tackle a typical exam question that combines everything we've just learned.
This is a super common type of question in ICSE exams. We're given this equation and we need to find the values of a and b. The plan is pretty clear. We need to take that messy fraction on the left, clean it up using rationalization, and then just compare it to what's on the right.
So let's walk through it. Step 1. Identify the conjugate. The denominator is 2 minus root 3, so the conjugate is 2 plus root 3. Step 2. We multiply the top and the bottom by that conjugate. Now, the numerator becomes 2 plus root 3 squared, and the denominator becomes that nice difference of squares, 2 squared minus root 3 squared. You do the math, and the whole thing simplifies down beautifully to 7 plus 4 root 3. Much better.
And now for the final easy part. We have 7 plus 4 root 3 is equal to a plus b root 3. All you have to do is match them up. The rational part, a, has to be 7, and the part with the root 3, b, has to be 4. And there you have it. Problem solved. You've found a and b.
So let's just do a final recap of our two number families. You've got the rationals, the predictable ones. You can write them as fractions, and their decimals either stop or they repeat in a neat pattern. Then you have the irrationals, the wild ones. Can't be written as fractions, and their decimals are just endless, patternless chaos. That's the core difference.
And that is your complete guide to rational and irrational numbers. Now you can totally spot the difference. But here's a little something to think about for next time. We have said that root 2 is irrational, but how would you actually prove that from scratch? It's a really cool proof, so look it up. Keep practicing these problems and you'll absolutely master this chapter. Thanks for watching.